In this video, we're going to talk about how we can run the open source Whisper model locally using the faster Whisper library, which actually does transcription much faster than, say, OpenAI's Whisper API. This is actually part of a larger project in which I'm building two-way voice chat with Opus, which actually works very well, but it's a pretty complex setup and an installation process. So I wanted to just make a video separately on the local Whisper, the faster Whisper. And then probably tomorrow or the next day, I'll actually make the video on this. But just to show you, when we run this two-way chat, which is powered by the local Whisper, we see that we loaded a large V2 model. There's a V3 model as well into my VRAM memory in my GPU. Actually, the large V3 works as well. I was just testing different things. Also, there's different ways of actually loading the model with int8 float 16. Also, you can use CPU if you don't have a GPU. You can actually run it on your CPU as well. Of course, the inference in that case would be slower. But this larger project, two-way voice chat, is going to feature local Whisper model, Claude 3 Opus, and 11 Labs real-time WebSocket-powered streaming responses. So it's going to work like this. I'm going to say something to the model. Hey there, how are you doing? See, we got transcription very quickly. We are waiting on Opus. Sorry, I actually ran the wrong file, but this is it. Let's try again. Hi there, how are you doing? Transcription's super fast. And Opus starts typing.
Doing well, thanks for asking. Excited to dive into some engaging conversation and explore
ideas. And we can actually
together.
interrupt the conversation by pressing spacebar.
I'm always eager to hear new.
Can you tell me about large language models?
Language models are fascinating computational systems that can process, generate, and understand human language.
As you can see, the audio starts immediately before the streaming from Opus is completed. So this is what I was trying to accomplish as fast as possible. So this works really well. Of course, it does have a few hiccups, but so this is a complex project. I just wanted to showcase it to you. But underlying one of the powering models, running locally, is the faster Whisper model. So I'm going to talk about that and how you can install it, because the installation process do require a few tricks as well. Code files for this project will be available at my Patreon at the connoisseur level. Also, I have two openings for the AI Virtuos 3 level. This comes in one-on-one meetings every month for 1 hour. If that is something you were interested in, if you want to get in touch with me one-on-one or need help with your project, maybe you can consider this. Also, I have lowered the Devon-like Opus autocoder code down to connoisseur level as well, if that is something you would like to check out. This one uses Opus as an autocoder, but it actually also executes code using both Docker and local mode. You can watch that video at my YouTube channel. So I have set this code up so that you actually start recording your voice by holding the spacebar down. And when you're done, you just lift it up and all of the transcript happens for you. And then we just print it. Once you have the full transcription with the transcribe audio method, you can actually do whatever you like. So let's run and test this. Actually, we are using the V3 model, I believe, currently. I hope sometimes it has difficulty loading up into the VRAM, especially if I exited out of the program and got back in because some residual memory still remains. Let's see. Okay, well, we were able to load it. So now we can just talk. Perhaps I'm just going to press the spacebar and say, I'm testing this for my YouTube viewers. Let's see how this goes. I used up. It detects the English, and I'm testing this for my YouTube viewers. Let's see how this goes. It actually detects the language automatically. For example, I can say, Je comprends un peu français. And it detected as French, for example. Let's try German. Wie geht es Ihnen? Okay, I believe that means how are you? So it's pretty good. It's very fast. That's the beauty of it. This normally would take a few seconds with OpenAI's Whisper API, especially with the internet speed. You can actually also run it locally with CPU. I actually never tried that. Let's actually go ahead and try it. I'm curious to see what will happen. Okay, we were able to load the model, but I believe we loaded into memory, actually, and the CPU actually fired up. That's why I wasn't able to unpause to record my audio, but the GPU memory is empty. So let's go ahead and transcribe something. Hi there, how are you doing? 1, 2, 3. So the recording is stopped. And as you can see, this is a bit slower, and our CPU is gearing up. This is a bit of an older laptop. Yeah, so it's not very fast in this case. Yeah, okay. So it has taken 7 or 8 seconds. So that's not great if you have a great CPU. Perhaps this will be faster, maybe 2-3 seconds, maybe similar to getting a transcription through an API, but I guess you can still use it, I suppose. Just keep that in mind. So we just tested it with that. You can also run it as int8 float 16. So let's talk about the code, and then we'll talk about how to install it. So the requirements for this is faster Whisper, and the thing is that you're going to need CUDA and QDNN, I believe, which we're going to talk about. There are installation instructions, but for some reason I found this issue. I had to actually downgrade the C-Translate. Faster Whisper actually installs C-Translate 4.0, I believe. So I had to downgrade to be able to use the QDNN the right way, and then we need Pi input to input keystrokes, in this case the spacebar, to start recording, and sound device to capture the audio. And then we pretty much define a Whisper transcriber class. You can decide on the model size. There's V3 and V2. Here's the sample rate to record audio. And then these are the attributes. You can initialize the model, like I said, with float 16, int8 float 16, or CPU, just int8. We declare a global attribute, right, for this class, is recording false. Then we have an on press. Then when we on press, if we are not recording, then we set is recording to true. We print recording started. And when we release the keyboard, if we are recording, then we set is recording to false and recording stopped. Then recording audio requires NumPy to be initialized. I guess I should put it in the requirements. We do initialize an empty NumPy array, and then we frames per buffer. I believe you can play around with this, but I'm not an expert in audio, so I'm not sure, but this works in our case. Then with keyboard listener, we pretty much, if we are recording, then SD imported sound device imported as SD. We're going to start recording. SD.record frames per buffer. It takes in these parameters, and then it waits, and then it does some computation here. And this is this infinite while loop. We're continually checking is recording. When we release the spacebar, then we're no longer recording. We break out of this, and then we join, I believe, the entire recorded bits. And then we return the recording, and then we have a we save this to a temporary file, and then we use transcribe audio, which is going to use that temporary file and use the model.transcribe file path. I'm not sure what this beam size is, but default was set to 5. Then we print the detected language with probability. So this transcribe is going to return segments and info. Info has I believe, many information in it. I haven't looked into it deeply, but it has definitely the language and also the language probability, which we were printing earlier. It auto detects the language, so that is nice. We initialize a full transcription, empty string, and then we loop over the segments, which is returned by the model.transcribe, and now we get the segment.text, and now we print each text, and now we append it to full transcription. Then we remove the temporary audio file, then we return the full transcription. It is a run method, which actually calls all these methods to record audio, save temp audio, and transcribe audio, and then just prints information. And when the script is run, we just run the run method. So this is it in a nutshell. You can use this locally. If you have my video card has 6 gigabytes of video RAM, and it actually works fine. So if you have at least that, you should be okay. And if you don't, you can still run it with the CPU mode. So now before we start talking about how we can install it, I just want to say that if you are enjoying my content, you can visit my website at echohive.live and watch all 250 plus coding videos that I've done, almost always dealing with large language models, building interesting projects, whichever I find most interesting at the time, exploring many different domains. And if you're a patron, you can find the code download links just by clicking. And if you become a patron, you'll have access to over 200 project files. You can actually download them, modify them, make it your own. So it really is a great convenience. And also you'll be supporting me at the same time. And if you do become a patron, I do appreciate that very much. You can also check out some of my other projects, such as AutoStreamer and CodeHive. Okay, so let's talk about Faster Whisper. I'll put the link in the description. As you know, Whisper is actually an open source model by OpenAI, and this repository offers a very fast version of it, which you can implement locally. You can read all about it. It actually talks about installation instructions. You pretty much install this library by just pip installing Faster Whisper, and then here are some example code pieces you can use. But see, what happens is, yeah, here we go. GPU execution requires the following NVIDIA libraries to be installed. So sorry, I say QBLAS and QDNN. I think it's both from CUDA. And you can go and follow the official installation instructions, but I am on Windows, and I think the proper installation for QBLAS was not available at the time. But there's this other installation instructions, and what I did was, so here it says download the libraries for Perfuse. So here is installation instructions for using Docker for Linux, for example. So just read through this. You can install it like this, or it says Perfuse Whisper Standalone Win, which is actually another interesting library which you want to check out. It's a standalone executable, but this is the single archive is what I clicked on. And right here, you can actually find downloads for Linux and Windows. I believe I downloaded this one, or this one, I believe. So once you download it and unzip it, you're going to see this type of DLL files. And you just have to point your system's path variable to wherever these are, or you can actually go to Windows and put it under System32 folder. I actually put them down here somewhere, so it's there here somewhere. The reason is because System32 folder is automatically in the path. If not, you would have to go to your environment variables and click on this environment variable, and it's going to open to a window. I don't want to open it since it has my API keys, but at the bottom portion, there's a path. And you just have to add to that path the folder which contains these files that we were talking about, these DLL files, and then you will be good to go. And another thing is that when you pip install the Faster Whisper, you will most likely going to have to downgrade the CTranslate 3.24.0. So what might happen is that if you install Faster Whisper and then try to install this, usually speaking, it may say that the requirements are already satisfied and not installed. So you may have to do pip install and the name of the library, like the version, along with the version number, and then -- upgrade, I believe. So this will force it to actually downgrade it to the version number that is necessary. And I found this at their issue right here, and I put the link here if you wanted to go there and check it out. This is where I actually realized CTranslate 4.0 might not work with you, so therefore CTranslate 3.24.0 works best. Also, the link to this QBLAS and QDNN is here as well, the download link. So this is it. If you can get this working, you'll have super fast local transcription. You can use this to control all sorts of stuff, build new cool user experiences, such as I'm trying to do with this two-way chat. So this is about it. I hope you enjoyed this. I'll be making the video on this two-way voice chat, which works really well. It's an exciting implementation, hopefully very soon. Thank you for watching, and I'll see you in the next video.